Steinhauer here. Welcome back. Finishing up our conversation about the Milky Way galaxy with the very interesting object that lies at the very center of our galaxy. And you see some orbits here. We'll talk about that in a minute. But let's zoom in on this spot little by little. On the left, you see a visible light image of the region around the center of the galaxy. You can see it's obscured by a lot of dust and other materials that makes it difficult to see through the disk of our galaxy, some 26,000 light years away, to what lies at the very center. But if you look at other wavelengths, those wavelengths can pass fairly easily through the outer part of the galaxy and through the dust and gas that incorporates the disk of the galaxy. And if you look at the same region from the radio perspective, you get some very interesting phenomenon that happen near the center of the galaxy. There's all this wispy radio emission here, and specifically at the very center of our galaxy, this spot right here, you see a very bright radio object. We call this thing Sagittarius A star because it's in the constellation Sagittarius, and it is the brightest radio source in the constellation Sagittarius. So zooming in even further on this particular region, we see in the infrared, we can see all kinds of interesting tendrils of light emanating from what seems to be a very interesting point in the very center. If we zoom in even further, we see and look at this thing in the near infrared, we can see all kinds of stars there. And many of these stars are physically located in this region of the galaxy, and some of them are orbiting a very interesting object. At the distance of at the center of the Milky Way, this line here represents 1 light year in diameter. This is a much more crowded region of the galaxy than we are in right now. You remember that the closest star to the sun is Alpha Centauri, and it's over 4 light years away. So you were to draw this picture around the sun would be in the middle, and there would be nothing else there in this diagram. The closest star is 4 light years away. But look at hundreds of stars within 1 light year of the center of the galaxy. Here you see an animation showing how the stars in the center of the Milky Way galaxy are moving. And they are moving in a way that reveals some very interesting things. So you'll notice the closer that stars get to the center of this image, the faster they seem to be moving. And in fact, they're moving incredibly fast. As some of these stars pass right around whatever object is there, they seem to be moving at substantial fractions of the speed of light, even 20% the speed of light or so. It seems to be that there's something happening right in the middle of this diagram that's causing all of these stars to move in this odd way. In fact, there has to be something very massive there. When we plot the motions of the stars that are nearby to that object, we get a diagram that looks like this. This is plotting where they moved from 1995 to 2002, which is about the image that we were seeing before. I think that went from 96 to 2008. But here we see the innermost stars and what their orbits look like. They've named them unoriginal names like S01 and S020 and S02. But you can see they're all orbiting in elliptical orbits around some object that seems to be centered on this plus at the center of the screen. And we can do some simple math. In fact, it's one of the labs that you'll do is take the orbit of S02 and calculate how massive an object it must be orbiting to be going as fast as it is at the distance that it is away from that object. And when you do that, you get that the thing that this is orbiting must be about 4 million times more massive than the sun, which is amazing. This is a half an arc second on the sky, which is already an amazingly small unit of angular measurement. These guys are orbiting much smaller even than that. But in this scale, at this distance, this is 4,000 AU. The semi-major axis of some of these stars are in the hundreds of astronomical units. And some of these stars get within just 100 or so astronomical units of that object at the center. So we know that this thing, one, is very small, less than about the size of our solar system, and 2 is not emitting any light. So what is this thing? Its mass is 3 to 4 million solar masses. Its radius has to be much less than the solar system, but we've in fact know that it has to be less than about an astronomical unit. There's only one thing that this can be, and that is a black hole. So we think at the center of our galaxy, there is a black hole that is millions of times more massive than the sun. And in fact, when we look at other galaxies, every single one that we see seems to have a supermassive black hole at its center. So the Milky Way isn't unusual in that sense. Okay, that ends our discussion of the Milky Way. We'll come back in the next class and talk about other galaxies and how they are different and the same as the Milky Way. See you then.